physics. So we have gone to what? We have gone to the mechanics. We have gone to the mechanics. Again from mechanics we have gone to the what? We have gone to the kinematics. Again from kinematics we have gone to the what? We have gone to the translatory motion or translatory motion. Okay. Again from translatory motion. So we have taken it from rectilinear motion. Rectilinear motion. Okay, this rectilinear motion is nothing but what? It is nothing but your straight line motion. Straight line motion. Okay. So finally we reached in last class we have reached our topic name, that is the motion in straight line or straight line motion, or this is also called as what? This is also called as motion in one dimension. Okay. So now today we will discuss about the again to start this chapter or to study this chapter, some parameters are required. Okay. So what we call it as? We call it as motion parameters. Motion parameters. Okay. That means what are the tools? Suppose we are going somewhere. Suppose we are starting with some work. We have to take some tools, some parameters. What is the required for that? If you want to write, first you will collect the pen, paper, everything. Like that. What are the necessary important terms required to study the motion or to study the motion in straight line? Those things we are going to recall in the motion parameters. Those all things you know. They are nothing but what you will discuss: displacement, what is frame of reference. All those things we have discussed in the your bridge course. Okay. So motion parameters. So first, very important thing here is, and that is what the new word maybe to you. That is what point mass, or it is also called as what? Point mass object. Okay, point mass object, or simply you can call it as point mass. Okay, you can call only point mass or point object or point mass, whatever. Okay, so now what is this point mass? The word is only saying, only suggesting what exactly it is. We are not going to consider some KSRTC bus to study our motion this to describe the motion, or to study the motion chapter. We cannot purchase the big bus and we have to consider that one. We cannot take car also. We cannot take some other your bike also. Why? It is not possible. We have to be sit in the ground, then allow the bike or car to travel, then note down. It is all not the it practically difficult to study that word. So instead of that one, we will consider the point mass. What is that point mass? It is the smallest thing we are going to consider. And smallest thing means it should be very small. It should be like or it should be a size of pen, or it should be a size of car. What it is again? What exactly that point means? What are you saying about this point, or are you saying about this something point, or something of bigger? What exactly that point mass is? Suppose if you take the point mass means only this much point mass, then how you can study, how you can make the more of that? So what exactly meaning of that point mass? I will tell you, the point mass may be a smallest thing. A point mass may be your vehicle also. The car may be sometimes point mass, or bus may be sometimes point mass, or your pen may be sometimes point mass, or the very small dot may be the point mass. Then what exactly we are talking? We are saying point mass, but I am saying your vehicle also may become point mass. How the bus or car will become the point mass? Or then what exactly point mass is? It is not the fixed mass. It is not the term which is always fixed. It will change with the situation. It will change with the situation. Suppose Suppose a car is moving from here to here. Suppose you are having the car and that car is moving from here to here, A to B. Okay. For this much distance, car is very big size. Try to understand. For this much distance, this car is going to be of very bigger size. Instead of that, but if I take the same car for this much long distance, A to B, and car is, I will take the little smaller. Okay, so this is what your car. For a very long distance, now this car is what seems to be very small. Getting it? For a very small distance, for 100 meter, car size is very big. To travel from here to some Delhi, to travel, if you take the distance from here to some Belgaum, if you take a distance from here to some Bijapur or somewhere, so what will happen? For that much large distance, when you see from some other distance, so that car is going to be what? That car is going to be very small. So in this situation, this car is going to be what? It is going to be point mass. For this situation, this car is going to be what? Point mass. But for this situation, it is not point mass. It is not a point mass. I hope you may be getting something. But if I take a small distance from here to here and I will put one dot. Now, for the same distance from A to B, this point is what? This point is point mass. You can say this point as a point mass, but this car is not a point mass for that much distance. I hope. For 100 meter, your bike may be, your bicycle may be going to a point mass. For 1000 meters, car may be going to a point mass. For some 5000 kilometers, your bus is going to be a point mass. That means it is not fixed. Point mass is not fixed. It depends on the distance you are considering. If the distance is very large as compared to the size of object which you are consider, then that object is going to be what? Then that object is going to be a point mass. Okay. So how I can write the point mass? The distance traveled by an object is very large as compared to its size, its own size, then that object is considered to be what? Then that object is considered to be what? Considered to be point mass. That object is considered to be point mass. I hope you may get the little thing about the clarity about the what exactly point mass is. Point mass is what? Whenever any object, it may be a bigger one or it may be a smaller one. If the distance traveled by that is very large as compared to the object, then that object is going to be what? Then that object is going to be a point mass. Suppose car travels some 1000 kilometers. For that 1000 kilometer, car is what? Point object. If it travels only 10 meter, then car is not going to be a point object, because 10 meter can be comparable with the size of the car, but 1000 kilometers cannot be comparable with the size of car. For that very long distance, car is going to be very minute. Then you can call it as the point mass. Getting the point? So that is why the concept of point mass or point mass object is what? It is a relative term. It depends on the distance traveled by an object. And you know very well, and you have studied in the bridge course, that is what we call it as frame of reference. Frame of reference. frame of reference. Okay, so how we can define, or what exactly frame of reference? Okay, so it is a system. It is a system. It is a system to which set of coordinates are attached. Set of coordinates are attached, and with reference to which, and with a reference to which, and with reference to which an observer can describe the position of an object. Okay, so this is what the definition for frame of reference. It is a system to which set of coordinates are attached, and with reference to which an observer can describe the position of an object. But how many of you can understand what exactly frame of reference with this definition? Okay, what we have to concentrate is to describe the position of an object. We have already studied, to describe the position of any object, what we require is, we require a reference point and the direction in which it is there. Okay, so for that only, to describe the position, what is required? One is reference point. Directions means what? The set of axis or coordinates. Set of axis. These two are required to tell the position. That is what included in the definition. To set of coordinates means set of axes are attached, with reference to which an observer can describe the position of an object. Okay, we'll see what exactly the frame of reference. We have to take a set of axes. Or set of coordinates. How we have to take? We have to take three axes which are perpendicular to each other. Okay, take these three axes. Okay, x-axis, y-axis, z-axis. They are perpendicular. Okay, so suppose if I take three axes, this one is here. This is what x. This is what y, and z is going to be here. It is in this direction, means it is going to be away from the board, means towards you. This is what the set of coordinates or set of axes. Okay, so it doesn't mean that they are in only one direction. They are there here also. That what we can take it as negative. Okay, that we will discuss later. Don't worry about these dotted lines. Okay, so that means they are like this. This is what y-axis and this is what x-axis, and this is what the z-axis. They are like this. Okay, so now, so what we have considered the rectangular system of three perpendicular axes. How many axes are there? X, y, z. So what we have considered? We considered set of three mutually perpendicular axes. Got it? We have considered a set of three mutually perpendicular axes. Okay, so mutually means they are perpendicular to each other. If this is perpendicular to this one, this is perpendicular to this one. Okay, so that is perpendicular to that one. Okay, so that is why we have considered a set of three mutually perpendicular axes. To describe position, what is required? This is required first one. Then reference point is required. Then what is the reference point? The point of intersection where they meet each other. This point of intersection is what it is called as reference point. So point of intersection of mutually perpendicular axis, are called, or is called, it is what it is, a reference point. This is what the reference point. The point of intersection of mutually perpendicular axis is what? Reference point. This point you can take it as O. That is what going to be considered as the reference point. These three axes are going to be what? They make a set of axes. Okay. So this is what required to tell the position of any object. Now one more very important thing is to tell the position of object. Suppose it is at point A. So when you want to say it is rest or motion, you will see after some time. So what is required to describe the position? Again, you require is what? You require the time. Okay. So what is required? So a watch is required, or time is required. Time is required to describe the position. Okay. So that is what. For that, what is required? What is required is watch is required. Okay. So now we can conclude something. What exactly frame of reference? What exactly frame of reference is? These all three together you can call it as frame of reference. That is what? Three mutually perpendicular axes which give the origin. What is that? The point of intersection with time or with watch. These all together you can call it as what? We can call it as frame of reference. Okay. So then how we can define what exactly it is? Suppose your object is here. So say it is at a distance x. Okay. What about y? Y is 0. Then z is also 0. So how we can write? We can write x comma 0 comma 0. Okay. Suppose it is somewhere here in this space, somewhere here. Okay. So x is also we can take like this. Where I can take this object is I can take this object somewhere here. Okay, I will take object somewhere here. That means it is in this space. Okay. Suppose if I take three perpendicular axes, the object is somewhere here. Okay. So now if that is there, some x distance is also there, some y distance is also there, some z distance is also there. What is that z distance? This is what z distance. Okay. So this x y z, this x y z coordinates can describe or tell the position of object in this system. Okay. So for time, what is required? For time what is required? Clock is required, or watch or clock is required. Okay. So this system of coordinates or the system of axes, this system or set of coordinates or system of coordinates, this set of coordinates along with watch is called what? Frame of reference. Okay. So this may help you to understand what exactly. When you tell something position of object, you have to mention what? How much it is distance away from x and y and z. Okay. So that will tell the position. What is required again? Time is also required. Okay. So for time, clock is required. So this system of axes which you are going to consider, along with the clock, we can call it as frame of reference. Okay. The definition though for writing the exam, that is there, which we have written in the beginning. Okay. So now what exactly it is? This is a system which you are going to consider. It is not a standard. It is like a empty bottle. Okay. So you can take anything here. X you can take distance, and Y you can take time. It will become a distance time system. You can take velocity here. You can take time here. It will become velocity time. That depends on you. These three axes are not what specified. You have to give the what measurement you want to measure or what you want to describe. Okay, they are just like what empty bottle. If you put the water, it will become water bottle. If you put the milk, it will become milk bottle. If you put something else, it will become something else bottle. Okay, so it depends on what you are putting in that one. Like that, these three axes are going to be defined by whom? By you. Okay, what you are going to consider. Once you define, once you consider, that is what going to be what? That is going to be your frame of reference. What is one-dimensional motion, two-dimensional motion, or three-dimensional motion? So first we'll see one-dimensional motion. One-dimensional motion, or simply you can say 1D motion. Okay. What exactly one-dimensional motion or 1D motion? It is the motion of an object in straight line. The object will move only in straight line, means only along one axis. Okay. So if car is here, if car is here, to tell the position of car, what is required? Only X is required. This, if you take this, now this may be a path. Car is what object. You have to consider what? You have to consider the frame of reference. What you have to do? You will take this as Y, and you will take this as X. You will take this as Z. Okay. If car is moving only in this direction, it is not jumping also, it is not coming on this side also. This is moving in what? It is moving in a straight line. If it is moving in straight line, to tell object position, suppose from here to here, say it is at X distance. So what is required to tell the position? Only X is required, means only one coordinate is required. You will say it is at distance 10 meter. Over. No need to tell how much distance is along Y, along Z, because it is not moving only in that. So X, Y and Z are going to be what? Y is also going to be 0, Z is also going to be 0. Means it is not coming only along Y and along Z. It is moving only along the X axis. So what you can say X comma 0 comma 0. So if it is 0, 0, not required only. So to tell the position of an object, to describe the position of an object, what is required or how many coordinates are required? Only one coordinate is required. That is what? X coordinate. That type of motion is called as what? 1D motion. Okay. So how we can define? If motion requires, or to describe the motion of, what you can write? If only one coordinates. If only one coordinate. If only one coordinate is required to describe the position or motion of an object, then it is said to be, then it is position or motion, you can say. Then it is said to be one-dimensional motion. Then it is said to be one-dimensional motion. You can write it as position also, or you can write it as what? Motion also. Okay. So that type of motion is called as what? One-dimensional motion. Or if it is moving in only one direction, means what you can call? You can call it as straight line motion. So if you don't want this definition, you can write that definition also. Motion in straight line. Motion in straight line. Motion in straight line is called what? One-dimensional motion is called one-dimensional motion. Okay. So similarly, two-dimensional. What exactly? 2D motion or two-dimensional motion. Okay. Now suppose you are having a table. Okay. So if this is your table. Okay. So now you are having an object here. Suppose one book is there. Okay. Now this book can move in any two directions. What is that? It may move in this direction, this or this direction, or it may move in this direction. Getting the point? So if you consider set of coordinates, what you can take? So suppose this is what this is one axis, this is one axis, this is one axis. Okay. What have taken? X, Y, Z. So X, Y, Z. Now suppose book move in this direction, X will change. Suppose book comes here. Suppose books comes here. It comes this much X distance and this much Y distance. Getting the point? So to tell the position of object, how many coordinates are required? Not Y, Z. You require X and Z. Y is what? Y is 0. Why Y is 0? Book will not jump. Book will not move in vertical direction. Okay. So how many coordinates required? 2 coordinates are required to describe the position of an object. Okay. So if two coordinates are required, if two coordinates are required to describe the motion or position of an object, then it is called what? Then it is called two-dimensional motion. Then it is called two-dimensional motion. Or if you want a simple definition, what is this? This is going to be a plane surface. Okay. So you can write like that also. Motion in plane is called what? Is called the two-dimensional motion. Is called two-dimensional motion. Okay. So similarly, we'll see about the what is three-dimensional motion, 3D motion. So what exactly 3D motion? 3D motion means you can take a bird. Okay. So if you take a bird, so bird is flying. Bird is flying means what? It is in the space. To tell or to describe this, you will consider 3 axes. Okay. You will consider 3 axes. Now it is there, say somewhere here. Okay. So to tell about that one, bird may go along X, it may go along Y, it may come along Z. If it is here, it is some X distance from the origin, some Y distance from the origin, from some Z distance from the origin. So to tell the position, what is required? X, Y, Z. All 3 are required. All 3 are required. It is here. This is what the position of the bird. This is what X, Y, Z. How much height is there? Y. How much away from the X, along the X, it is, say some X, from here some Z. So it required X, Y, Z. So how many coordinates are required? 3 coordinates. So if 3 coordinates are required to describe the position or motion, of an object, then it is called what? Then it is called 3D motion or 3-dimensional motion. Okay. Or if you want simple definition like this, where bird is flying in the space. Okay. So simply what you can write? Simply you can write it as motion in space. Motion in space is called what? three-dimensional motion or 3D motion. I hope you understood what is one-dimensional motion, what is two-dimensional motion, and what is three-dimensional motion. Okay.